So here, we are solving capacity problems. And capacity is just another word for volume. So really, we're just looking at these objects. Many of them are composite objects. And we're figuring out the volume. So we're still going to use those volume formulas that we've been using so far. So example, determine the capacity of the mailbox shown to the right. So here we go. Here's a nice, lovely mailbox. All right. It is a combination of two shapes. What are the shapes? Thank you. Yep, cylinder and rectangular prism. So what we're going to do is we're going to find the volume of the rectangular prism. And is it a complete cylinder? What kind of cylinder is it then? Half. So we're going to find the volume of half a cylinder and the volume of the rectangular prism, and then we're going to add them together. So we'll start off with the rectangular prism because the calculation of that ought to be a little bit more straightforward. It's just because the volume of a rectangular prism is length times width times height. What's the length? What's the length of the rectangular prism?
20.
Sure. What's the width? Sure. What's the height? Cool. 20 times 8 times 6 is 960 inches cubed. Okay? That's the volume of the rectangular prism. Now, the volume of the cylinder. So he says half a cylinder. Okay. So the formula for the volume of a regular cylinder, so that means a wholly intact cylinder, is pi r squared h. That's the formula for the volume of a whole cylinder. But if it's half a cylinder, then we're going to divide it by 2. And now it's half a cylinder. So, and this is a little tricky. We need to know what's the radius of the cylinder. Very good, it's 4. If you're not sure where that came from, if this is 8 right here, then this is 8 right here. 8 would be the diameter. So it's half of that for the radius. Half of 8 is 4. That's where the 4 comes from. The height. What's the height? 20. And we're off to the races. We need to make sure we do our order of operations properly. Exponents come first. 4 squared is what? 16. Times 20 divided by 2. Okay. Now, we have on our calculator, here's what I would do. I would go pi times 16 times 20 divided by 2. So pi times 16 times 20 divided by 2. And what I get is 502.65 inches cubed. So then the overall volume is 960 plus 502.65, and that's going to be 1462.65 inches cubed. That is our final answer. So that is the capacity of the mailbox. Okay? So we find the volume of the rectangular prism, the volume of the half cylinder, and the way we treated that half was we wrote out the formula of the regular cylinder, and then we divided by 2. We took those volumes, we added them together, and that's all we needed to do. Okay? Okay. Next example, here we go. Shaylin's cousin works at a farm. On the farm, there's a wheat silo. What's the capacity of the silo? So this is also the combination of 2 shapes. What shapes? Cylinder and a cone. And it's not a half cylinder or half cone, it's both are full. So we're going to go ahead and figure out the volume of both of those things and add them together. So we'll start off with volume of cylinder. And the formula for volume of a cylinder is pi r squared h. What's the radius? 6, very good. The height? 20. Good. Remember, when we work through this, order of operations is important. 6 squared is 36. So, 36 times 20 times pi, and the volume is 2,261.95 cubic feet. That's the volume of the cylinder. We know the formula for the volume of a cone is very similar to the formula for the volume of a cylinder. As a matter of fact, it's identical, except there's a 1/3 at the beginning. It's 1/3 pi r squared h. The bottom of the cone covers the top of the cylinder perfectly. So that tells us that the radius of the cone is the same as the radius of the cylinder. And that means the radius is 6. But the height is different. What's the height of the cone? It's also 6, yeah. Six squared is 36. When I went through and marked your work, I noticed that sometimes students had the exact right stuff. Like they showed me the exact right numbers and they worked it out perfectly. And then somehow they got oddball answers. When you work with your calculator, it's useful for you to take a look at your answer and say, does that make sense? And we can't always spot it, but if we see something on our calculator and we're like, that doesn't seem right, then maybe we'll find out we punched in something wrong or forgot to do something, and it'll help us get to the right answer. Here we're going to have 36 times 6 times pi, and because of the 1/3, we're going to divide by 3. So just to highlight what I said, because of that 1/3, we are going to divide by 3. When we figure out the answer, we're going to get 226.19 cubic feet. So now that's the volume of the cylinder above, or cone above rather. And now to figure out the volume of the whole thing, we're just going to add those together. And we're going to get 2,488.14 feet cubed. That's the volume of the whole thing. All right, one last example. Here we go. A greenhouse is built like the one on the right. Determine the capacity of the greenhouse. First of all, this is a great question. Reason why this is a great question is this is not a single shape, and it's really hard to turn this into two shapes nicely. You could say to me, well, we could turn it into a rectangular prism and two triangular prisms. Yeah, I guess you could, but we don't have enough information. So what are we going to do? Well, here's the interesting thing. Like this is, whatever this is a prism. And you can think of a cylinder as a prism. Of course, we have a rectangular prism. We have a cube. We have triangular prism. We've got all sorts of different prisms. And what's true about them all is if you can look at this right here, and if you can find the area of this front and then just multiply it by this length right here, that's going to give you the volume. The key is we have to figure out the area of that. Now that is a special shape. Anyone know what kind of shape that is? Trapezoid, very good. There's a formula for the area of a trapezoid. There is a formula for the area of a trapezoid. So a trapezoid in general looks like this. It looks like the front of our object. There's basically one condition. These lines have to be parallel. We say that's A. We say that's B. We drop a perpendicular down and we say that's H. And the formula for the area of a trapezoid is 1/2 of A plus B times H. That's the formula for the area of any trapezoid. Now, the front of our object is a trapezoid. So we can take that formula and copy it down here. Volume equals 1/2 A plus B times H, and that will utilize this, and this, and then we have to multiply it by the length, which is that L value. So that's our volume formula for this. We find the area of the front, which is a trapezoid, a common figure, and we're going to multiply that area by the length. When we have this A and this B, it doesn't matter which one's A and which one's B, the 3 or the 8. Doesn't matter which one's which. I'll use 3 because it's on top. 3 plus 8. The height is 5. And the length is 18. So that is 1/2 of 11 times 5 times 18. And it doesn't matter how you do it, as long as you do it in the right order. And there's not really a right order as long as you remember everything. You're going to get 495 meters cubed for the volume or capacity of that greenhouse. You have to, when you're using your calculator, incorporate that 1/2. So you could just divide by 2. So you can go 11 times 5 times 18, all divided by 2. And you should get 495 cubic meters.